Okay, so there are two objectives for today's lesson, mole concept and bonding. All right. The main objective is not to go through content, but really to revise how you can answer better in order to get the marks, especially for bonding later on. But let's start with mole concept. Now I've marked the homework. Now the way many of you approach mole concept is not wrong, but it makes you rather careless. Always highlight chemical names and numbers. So in this case, 4.5 grams of glucose. The first thing you need to know is what is glucose's chemical formula? It's actually here. It is very important, especially if you know you are very careless, to draw that line so that you know that, okay, the formula is C6H12O6. Okay? Now, some of you already made a mistake from 1A onwards. Your MR for glucose was wrong because you used the wrong chemical formula. So it is very important to know what is what. Glucose is C6H12O6. Of course, you have 100 cm cube of water. So this cm cube is the volume, right? So you need to know that, okay, I have 4.5 grams, that's the mass, and then now I have 100 cm cube, that's the volume. This will tell you which triangles to use later on, okay? So for 1A, you are asked to calculate the relative molecular mass, okay, MR of glucose. Now, another way to phrase this is, of course, molar mass. So we have already gone through this. Relative molecular mass and molar mass, they are the same number. The only difference is relative molecular mass has no units, molar mass has a unit. Okay, so how do you calculate MR? I think it's very straightforward. However, you need to show the substitutions. Now, what do I mean by substitutions? I mean this. Please show the working, like 6 times 12 plus 6 carbon, 12 times 1, 12 hydrogen, and so on. And this will give you 180. So the MR is 180. The molar mass is 180 gram per mole. Okay, so you need to know they are the same number. The only difference is whether it has unit or no unit. So MR got no unit, molar mass has units of gram per mole. Okay, next. Now part B is the main reason why I wanted to go through this actually. If you look at your TYS, this whole thing about concentration in grams per dm cube and moles per dm cube is very, very important. It comes out very often. You are expected to know how to convert between gram per dm cube to moles per dm cube. So let's revise this whole concept of concentration to start with. The triangle is NCV, where C is concentration. Concentration is the number of moles over the volume, right? So this will give you mole divided by volume, dm cube. So the concentration's unit is moles per dm cube. All right. So how then do you do this? I need moles first. I know I have 4.5 grams of glucose, right? So if I have 4.5 grams of glucose in 100 cm cube of water, gram cm cube. You can't use it like this, right? The first step is that you must convert 100 cm cube to dm cube. To convert, we divide by 1000. So this gives you 0.1 dm cube. Have this number ready, 0.1 dm cube. Next, you can't use 4.5 grams as is. You will need to convert it to mole. This is why you calculated the MR in the previous step. If you have calculated the MR, it's a matter of taking gram to mole. Gram to mole, we take gram divided by MR, which is 0.025 mole. Again, have this number ready somewhere. Okay? Once you have this, of course, I'm sure you can imagine, to calculate concentration, I take number of moles divided by volume. 0.025 mole divided by 0.1 dm cube, which gives you 0.25 moles per dm cube. Okay? So that's in moles per dm cube. However, now you are asked, what if I wanted gram per dm cube? So you need to know how to convert. From mole to per dm cube to gram per dm cube, the conversion is what? Actually, you don't need to learn something new, right? You just need to know how to convert mole to gram. How would you go from mole back to gram? You times the MR. So you take 0.25, the answer for the previous step, times the MR, which is 180. If you do that, actually it's just this. Okay? So this is a very typical combined science mole concept starter. You must be very, very good with moles per dm cube and grams per dm cube. And how do you convert between the two? Okay? Now at this juncture, can you ensure that you can do this before we start the next part? So this is question 1B on moles per dm cube and gram per dm cube. Okay? Now part C, many of you got lost along the way. Okay, so let's go through why you got lost for 1C, okay? Let me just go back to the question. And you should also have the question on your iPad, I think. Now, part C, the difficulty, of course, is this. Only 20% of the glucose was converted into ethanol. How would you make use of the 20%? It's 20% of glucose, right? 20% of glucose. Let's copy that phrase down. Okay, 20% of glucose. In the previous part, you have already worked out that glucose was 0.025 mole. You have already worked this out. Where do you work this out? Here. Right? You have already worked out 0.025 mole of glucose because you took 4.5 gram divided by the MR. That's 0.025. This is why writing the units is important. If you just wrote series of numbers, you wouldn't even know what's going on. You wouldn't even know that, oh my god, I already calculated moles. So the unit is very important. This is what I call working and presentation. It really helps you save time. In fact, not writing the unit and not writing working is a waste of time later on. So always write the units, always write the working clearly in a way that you understand. And once you got 0.025 moles, how would you use the 20%? 20% of glucose means 20% of 0.025, right? So the number of moles of glucose converted is 20% times 0.025, which will give you 0.005 moles. This is how you make use of the 20%. It's 20% of 0.025. 20% times 0.025. After you have done this, basically you have the number of moles of glucose which reacted. Now you want to find what? Carbon dioxide, I believe. Yep. So the carbon dioxide, 1:2. The mole ratio has to be shown. Even if the mole ratio is 1:1, it's the same number, you must still show it. Why? Why am I so insistent? I'm insistent because if your numerical answer is wrong, we need to trace backwards to give you working method marks. We cannot give you method mark if the mole ratio is not shown. Okay? Like I said, if your numerical answer is always correct, well and good. However, we can never be 100% certain. So please show working. 1:2. And it's also good to show working because once you show working, I'm sure you can calculate and fill in the blank. Because it's 1 glucose, 2 CO2, if it's 0.005 mole of glucose, to get CO2, I seriously just need to multiply by 2. Right? So 0.005 times 2, which gives 0.01. And we will finish off. How do you find volume of CO2? CO2 is a gas. Not everything is a gas, but CO2 is definitely a gas. If it's a gas, you can use Vn24. This is only for gases. You do not use Vn24. You do not multiply by 24 if it's not a gas. So what gases do you need to know? You need to know CO2 is a gas, hydrogen, oxygen, ammonia. These are all gases. All right, so in this case, 0.01 mole times 24, which gives you 0.24 dm cube. All right, can you leave your answer in dm cube or must you convert to cm cube? Don't worry, because the O levels will usually tell you what is the unit they want the answer in. So read the question or read the answer line for the unit. The question might tell you calculate the volume of CO2 in cm cube. Or they will tell you calculate the volume of CO2 produced. Full stop. But the answer line shows you cm cube. Then you must convert to cm cube. Okay? Can? So this is how you make use of the 20% of glucose in question number 1. And this is a good way of presenting your mole concept answer every single time. When doing mole concept, it's always convert to mole ratio. Finally, use one of the formula triangles to find answer. This is why mole concept is usually 3 marks. 1 mark, 2 mark, 3 marks. Okay, so please show the working. Even if your mathematics is good, show working. Now, the next question I'm going to go on to is question 4, I believe, or 3. Okay, but before that, can I just check, is 1C okay? Has everyone taken down what you need to take down? If you have, can you please give me a reaction button? I think you can probably send reactions. Yes. Okay, thank you. Okay, I presume we are okay. All right. So always present mole concept like this, regardless what's the problem. It could be concentration, it could be limiting reactant. The working is always going to look like this. Okay, do not give poor working. Okay, now we're going to apply the same 3 steps to do another question. Question 3. Now, question 3 is not a typical O-level question. Having said that, it's in syllabus and you're expected to know it. If question 3 comes out, I think it will be quite tricky for most students because it's a play on words. Okay? So how do you avoid getting tricked by words? First, please highlight the chemical names. Okay, you can match the chemicals so that at least you know what's the formula. Next, highlight the numbers. 6 grams of copper 2 oxide, again this is this, was added to 50 cm cube of 1 moles per dm cube HCl. That's that. Importantly, this was an excess of copper 2 oxide. So if it's an excess of copper 2 oxide, what does it actually mean? If copper 2 oxide is in excess, that means HCl is the limiting reactant. Now, this is important information because if you want to do part C correctly later on, you will need to know which mole ratio should I use. Should I use a mole ratio with copper 2 oxide inside it? Or should I use the mole ratio with HCl inside it? You should always choose the limiting reactant to be in the mole ratio. I repeat, the limiting reactant is the one that limits you. So you must choose the limiting reactant in the mole ratio, not the one in excess. Hence, if it's an excess of copper 2 oxide, we do not put copper 2 oxide into the mole ratio. We will instead ensure HCl is in the mole ratio. Okay? Now, based on this, can you see that I've annotated the question? This allows me to do the problem much faster and not get it wrong. No point doing the problem fast but wrong, right? You want to be accurate. So I think 3A is still easy. Calculate number of moles of CuO. Okay, this one is quite straightforward. I'll just show you the answer quickly. So it's just mass divided by the MR is 0.075 moles. So A is easy. 0.075 moles of CuO, copper 2 oxide. B already created problems because of this word used. All right. Now, how would you interpret this word used? Number of moles of hydrochloric acid used. The idea is the one that is used is what you have added in. Meaning, I added this concentration with this volume, right? The volume is 50 cm cube. The concentration is 1 moles per dm cube. So this is what you added in. It may not be what has reacted. Okay? So the word used literally just means, all right, how many moles of HCl did you add in? So you are given volume. Is this a gas? You could ask yourself. It's hydrochloric acid. If it's an acid, it's aqueous. Aqueous is not a gas. Aqueous is a solution. Therefore, the volume here is not the one where you have 24 dm cube. If it's an aqueous solution, the formula triangle to use is N, C, and V. All right. For aqueous solutions like acids, alkalis, salts, we will use NCV. So once you know it's NCV, I think the rest is quite straightforward, right? It's just concentration times volume, 1 times 50 over 1000. So again, some of you have forgotten, your 50 cm cube has to be divided by 1000. You must always convert cm cube to dm cube by dividing by 1000. Now, once you have done that, actually the rest is very straightforward, I think. Right? So A and B for 3 is there. Okay, so it's just a play on words. Used means added in. How much HCl did you add in? It's stated there 50 cm cube, 1 mole per dm cube. Okay, so we make use of that. The concentration is 1 mole per dm cube, and the volume is 50 cm cube. Okay, and finally, we will conclude. How do you find the mass of copper 2 chloride? Now, you all have to be very, very careful, please. You need to know what's copper 2 chloride. Copper 2 chloride is CuCl2 in the equation. Okay, very often, I think you all choose the wrong chemicals, and as a result, you won't get the answers because you need to be mindful what is what. So, copper 2 chloride is CuCl2. So, now we need a mole ratio to find CuCl2. What ratio should you choose? Like I said at the start of the question, choose wisely. The mole ratio should include the limiting reactant. The limiting reactant is HCl because copper 2 oxide is excess. So HCl is limiting. So the mole ratio you choose is HCl to CuCl2, which is 2 is to 1. Right? If it's 2 is to 1, okay, let me just write outside so that at least there's a bit more space. So we choose HCl to CuCl2, 2 is to 1. 0.05 moles of HCl. What is the number of moles of CuCl2? If it's 2 is to 1, it means that the left hand side is 2, got more, right? So the right hand side, 2 is to 1, we should divide by 2. 0.05 divided by 2 is 0.025 moles. You can use a calculator for that. After that, I think finding the mass is quite straightforward. Okay, times the MR, 64, plus 2 times 35.5. And I think the answer, if I recall, 0.025 times 3.38 grams if you round it off to 3SF. Okay? So, learning point, limiting reactant always in the mole ratio. Some of you had substituted copper 2 oxide, which is in excess. That's not allowed. Okay? So that's question number 3. Okay, so I hope you have done the mole concept homework for those in my group. If you have done the mole concept homework, I've marked it. You should be able to spot your mistakes now. And if you have followed my instructions and shown the working clearly, no mole concept problem is too difficult. Okay, now before we move on to bonding, I have one last thing I want to talk about in this worksheet. Now, this is question 3C, right? If you go to question 5, I'm not sure if those in group 2 recognize this reaction. You seem to have learned something similar just yesterday, right? So for those in group 2, we have done the Sin Min Sec paper. The Sin Min Sec paper had shown you a process called the Mond process, right? So in Mond process, we use nickel, but the reaction is actually remarkably similar. There are some slight differences, of course. Nickel has 4 COs inside its carbonyl. Manganese has 5. Okay, you don't have to remember these numbers, but for those in my group, yesterday we spent a bit of time discussing the Mond process. We spent a bit of time looking at different questions that could be asked from the Mond process. Okay, so for those in my group, in case you're still wondering what I'm talking about, yesterday we did Sim Min Sec, right? Mr. So even made you all do the part D, part E, part F, right? I added part E, part F yesterday during lesson. You need to be able to answer different sorts of questions based on just one reaction. Okay, so I hope you will take a look at it later on, the Sin Min Sec paper, what we had gone through about the Mond process. Okay, so going back to the mole concept so that everyone can just copy down 3C in case you have not. And then after this, we're going to go on to bonding. So the bonding homework, I believe I had disseminated to you via PDF. But in case you don't have it and you would like a copy of it now, let me just copy it out from my drive. Just give me a minute. It's loading. Just give me a minute. Okay, so I've just sent in the meeting chat a Google Drive folder. If you click on the folder, it will lead you to a folder of worksheets. All right, and now we're going to go through worksheet number 4, which is bonding. Okay, bonding. Worksheet number 4. Okay, I hope those in group 2 have already tried this worksheet, because what I'm going to do now for the next 30 minutes or so is to use this worksheet to demonstrate some problem solving strategies to do with bonding and atomic structure questions. Okay, so we need to learn strategies. Okay, not just do, not just memorize content, but strategies are also very important. How would you think through a question? What is an important word in a question I should pay attention to? How do I break down a question? All these are important. All right, so we will make a jump over to bonding now. Okay, so this is a typical O-level question. Okay, this is a prelim question from another school. Okay, now typically the first few questions of the O-level combined science paper 3 is a structured paper, will be a one word or one letter answer. So this fits the bill, right? It's a one letter answer, A, B, C, D, or E. Okay, please don't start doing immediately. Do not ever do that. The first thing you should do is recognize, okay, this is electronic structure. Electronic structure or electronic configuration means 281, 288, 27. This is an example of electronic structure. Okay, so if I were you, I would actually go and count and start writing. Of course, I'm assuming you will count properly, right? So I will count and start writing. Now, you might be wondering, what's the purpose of writing it when you can already look at it and tell? There is a purpose. The last thing you want is to misinterpret the diagram and count one electron short, right? You want to ensure that you write it out so that it's immediately visual to you. So the 288, 27, 2881, by writing it out, it's actually very clear cut to you. Now, these are electronic structures or configurations of 5 atoms. This is a key word, a very important word. You have learned words like atoms, ions, and molecules. So atom means what? Atom means the number of proton equals to the number of electron. That means how many electrons it has is equals to how many protons it has. So atom means proton equals electron. Okay? Now later on in part B, we will look at ion. And you will realize that for ions, the proton number is not the same as the electron number. Okay? But for now, it's atoms. So A288, there are 18 electrons. Therefore, there are 18 protons as well. Right? So 18 means which element is this? You go periodic table, you find element number 18. Element number 18 is argon. I will always write down the name of the element. Why? Now, why will become immediately obvious after we look at some of the questions. But we can continue. 27. 27 means 9 electrons, 9 proton. 9 proton, element number 9 is fluorine. We can continue. 2881 is potassium. Because 2 plus 8 plus 8 plus 1 is 19. Element number 19 is potassium, and so on and so forth. Okay, of course, it's just working, right? It's for your own good. It's just to help you. The moment you have the names of the elements and the electronic structures, to be really honest, answering these 5 questions is a sure in the bag 5 marks, right? Okay? Notice how quickly I did the 5 questions. I did it so quickly because I've already written down the electronic structures and I've already written down the name. Look at part 4. Which one is fluorine? It's so easy because you have already written down which one is fluorine. Just choose B. B is fluorine. Next one. Which is a metallic element? A metal. Which one is a metal? In this whole list, the most metal sounding thing is potassium. C. So the whole purpose of this lesson is to show you a key strategy is if you are given the number of proton or number of electron in the atom, please find out what is the element's name. Never ever work with unknowns. If you can use the electron to find out what's the element, go find out. Okay? It really helps. Next, you notice I've used C twice. That's okay because there's this instruction here, right? In fact, most of the time, each atom, each substance may be used once, more than once, or not at all. This is a standard instruction. So by default, for such questions, where you choose one letter or one word, okay, you could repeat it. So the same letter could be used for multiple parts as answers. So take note of that. Okay, so I hope we learned the problem solving strategy. Please do not leave the ABCDE hanging. You should know what is what, okay? And if you're wondering, will we test you on elements that you have not learned before? We can only test you on the first 20 elements from hydrogen to calcium. If we give you electronic structure, we can only test the first 20. So I think it's definitely something you would have seen in class before. Now, I would say that this is still pretty easy. All right. So since it's pretty easy, let's add on part 6. Okay, let's add on part 6. Okay, I hope you can see my screen. I think you can definitely see my screen. So which one provides an inert atmosphere for reactions to happen? Okay, of course, after finishing copying, I think the answer is quite obvious, right? This whole thing depends on your understanding of the word inert. So what is the meaning of the word inert? Now, you need to know synonyms, words that have the same meanings. Inert is another way of saying unreactive. So very often, to ensure that we do not have like other reactions happening, we need to use an environment, an atmosphere that is inert, that will not react with our substances. For example, whenever you are doing reactions with potassium, potassium is highly reactive. It reacts with water, even the water vapor in the air. It reacts with oxygen in the air. So if you wanted to minimize these unnecessary and unwanted reactions, we will use inert atmosphere. So whatever you choose now should be inert and unreactive, which I'm sure you know. The answer is A. Because argon is a noble gas, argon has a complete, fully filled outer shell of electrons. So it will not lose, gain, or share any more electrons. Okay, so hopefully you can see why identifying the names of the elements is helpful. Because if you identify the name, you will know immediately argon is unreactive. Therefore, it's an inert gas. Now, part B, if you have done a TYS, you would have seen this a number of times, all right, in different years. They love to test number of protons, electrons, and neutrons. The first thing to know is, hello, it's not in the usual order of proton, electron, neutron. You need to first look, where's the proton? Do the proton number first. I repeat, always do protons first. Why? Because proton number never ever changes. You never ever lose or gain protons. Meaning, if it's 19 protons, it will forever be 19 protons, regardless of whether it is an atom, ion, or even a molecule. Okay, so in this case, I'm given Cl 35, 17. The smaller number, 17, is the proton number. Okay, 17 is always true for Cl. Even if it becomes Cl minus, it's still 17 protons because proton never ever changes. What can change though is the electrons. So in this case, there's no charge. Because there's no charge on the Cl, we call this an atom. So the Cl atom. Because it's an atom, what can you say? P equals to E. 17 proton, 17 electrons. And finally, the number of neutron, 35 minus 17. Okay, this one I think most of you know. The issue is when we get to the next one. Okay, the next one has a charge. It's minus. When it has charge, it's no longer atom. It's called ion. When you see the ion's charge, first thing to do, take the charge. Look at it. It is 1 minus. 1 minus means it has gained electron. How many? 1. This is the first hurdle you must cross. A negative charge indicates that 1 electron has been gained because electrons themselves are negative. Okay? This is why we love to study for O-level combined science, because we know that this is a major conceptual barrier. Negative ions got more electron. Okay? They gain 1 electron. That means this thing has 35 protons because the bottom number is 35. But the electron is not 35. It's 35 gain 1. 36. So this is the one that is very difficult for most students. Okay? So let's practice more. So I'm sure you know by now, there's calcium. Calcium has 20 protons and 20 electrons. But how about this? If it was Ca2 plus, how many electrons and how many protons would it have? So protons never ever change. Proton is the same number throughout because you do not lose protons or gain protons ever. The one that changes, of course, is the electron. So now it's a positive charge. If it's a positive charge, it means it has lost 2 electrons. So the answer is from 20 electrons originally in the atom, now it has 18. All right. Now let's go one step further even. Give you something that, oh my god, never ever see before. All right, this is yttrium. Even Mr. So also don't know. Mr. So is Googling now. How many protons yttrium has? 39. Okay, so this is yttrium. Never learned before, right? How many protons and how many electrons does yttrium have? So I'm sure you can work it out. 39 protons, 39 electrons. Oh, and neutrons as well. How many? 90 minus 39, which is 51. So this is true for the yttrium atom, right? But what if I told you now yttrium forms this ion? How many protons, electrons, and neutrons would this ion have? So again, we go through the same procedure. Look at the charge. The charge is 3 plus. Circle the charge. 3 plus. Don't fall into the trap. Plus is not gain. 3 plus. Why is it positive now? It's positive because actually it lost electrons. How many electrons did yttrium lose? The yttrium atom, to form a 3 plus ion, lost 3 electrons, right? So originally it was 39 electrons. Now it should be 39 lost 3, 36. But the rest remains exactly the same. Okay? And with that, we come to another key understanding, which is positive ion is where you have less electrons than protons. It's positive precisely because you lost electrons. Ca2 plus lost 2 electrons from Ca, right? Y3 plus lost 3 electrons previously to form Y3 plus. So positive means it has less electrons. Negative ion means it has more electrons because it gained the negative electrons. So it has more electrons than protons. You will need this a lot. Okay, this is just question one. If you did the bonding homework, there is a lot of questions which resemble this that will require you to know the difference between atoms and ions, positive ions, negative ions. Okay, so I hope you take this down first. Now, I spent very long talking about this because I want to move on. And as I move on, I think it'll be faster once you know this. Okay, so the same concept, the same problem solving technique is used for almost every similar question of this sort to do with atomic structure and bonding. Okay, so now you can see the next question. Okay, for some of you, those in my class, you would have seen some of these before, right? Okay, it's not a new question. So again, you need to know where to start. This one is basically seven different particles, seven different particles. Notice they use the word particles. Particles means it could be either atoms or ions. You don't know which is which. You have to deduce it yourself. So where do you start? Always start with the proton number. Always start with the proton number. So A is proton number 2. What do you do with proton number? The proton number should tell you what is the element's name. Proton number 2 is helium. Proton number 6 is carbon. So you basically go down the line, do this periodic table search until you get everything out. Okay? Some of you might think, oh, this is a waste of time. It's not a waste of time. It is a waste of time if you don't do it because later on you'll find it very hard to get full marks for the questions that follow. So make sure you spend the time, take the proton number, go periodic table and flip. What is element number 2? What is element number 6? What is element number 7? And in fact, immediately I already know what the element is after looking at the periodic table and I can answer actually the questions very easily. Okay? Now, after the proton number is done, the next thing to do is always the electrons. What do you look at? Is the number of electrons the same as the proton? In this case, for example, A has 2 electrons. It also had 2 protons, right? So if it's the same, it's an atom. So A is a helium atom because the number of electrons equals the number of protons. B, again, 6 and 6, 6 electrons, 6 protons, atom. In fact, you could go down the line, I believe. Okay? Until you reach D. D has 10 electrons, 7 protons. So now you can ask yourself, okay, it's not equal anymore. If it's not equal, which one has more? Is it more electron or more protons? So I'm sure you can see D has 10 electrons, but 7 proton. 10 is more than 7. Electron more than proton, which is exactly what we copied just now. More electron means negative. In this case, it had 3 more electrons, so 3 minus ion. Okay, notice how I can deduce the charge even just from this. I know it's negatively charged because it had more electrons. It had 3 more electrons, so 3 minus. All right, so that's D. Is the N3 minus ion. Then we move to E. Again, it's different. It has 10 electrons but 12 protons. So 10 versus 12. 10 is less than 12. So electron is less. If electron is less, it's actually a positive ion. It's a 2 plus ion. which makes sense because you remember that magnesium is group 2, it forms Mg2 plus ions. Okay, and the last one is the atom of fluorine because 9, 9, they are equal. Equal number of protons and electrons is an atom. Okay, now you might find this very time consuming, but if you do this rigorously, you can do it very quickly. And once you have done this at the side, answering A part 1, 2, and 3 is so easy, right? And you will always get it correct. Okay? If you have just written out what's at the side, helium atom, carbon atom, you would have done very, very quickly. In fact, even the isotopes question is straightforward. I immediately know it's B and C. Why? It is because isotopes are atoms of the same element. They are the same element, carbon. They have the same proton number, 6. Right? The only difference is the different number of neutrons. That's it. So definitely B and C are your isotopes. Okay? Simply by virtue of your analysis that both are carbon, which is why this analysis is very, very valuable. Okay? Now, B part 2 is the type of question that you struggled with in prelims. Many of you didn't understand what was meant by describe the differences between the atomic structures of isotope this and that. So when we ask you for atomic structure, like in this case, subatomic particles, what do we mean? Subatomic particles is basically your proton, electron, neutron, right? So since this question used B and C, let's use B and C. So B has how many protons, which is the same as in C. So I'm sure you can quickly write B has 6 protons, which is the same as C, right? So when we are comparing, we don't just give differences, you must also give the similarities. So protons is the similarity, right? Both have 6 protons. Both B and C have 6 electrons as well. If you want to add on, you could say in their shells. So these are the similarities, the numbers of protons and the numbers of electrons. However, the number of neutrons would differ. B has 6 neutrons. How do I get 6? I take the nucleon number minus the proton number. 12 minus 6 equals 6. While C has 8 neutrons in its nucleus. How do you get 8? 14 minus 6 equals 8. All right. The biggest mistake for most of you in prelims, you didn't work out the number of neutrons. You just told me, oh, the number of neutrons is different. Cannot. You need to actually work out. How do you know when you must work out the exact number? You need to work out exact numbers whenever you are given data. Data like, oh, I have the nucleon number, I have the proton number. Data like, oh, I know this is the isotope because they told me the isotope is this. So if they told you specific isotopes, you need to give me specific numbers back. All right, calculate it back for Mr. So. All right, don't assume that we know. All right. So this was a question that many of you had difficulties with during prelims. Okay, now we are question 2 already. So we are already done with question 2. Before we go, I think we should try one question ourselves, especially since some of you have not done it yet. So may I just give you very quickly 5 minutes. Okay, let's skip some of these first. I would like you to try out question 4A and 4B of this. All right, using the techniques that we have been speaking about in class, okay, this lesson, how would you approach this question? Okay, I want you to try 4A and 4B. Okay, let me just give you 5 minutes, a short amount of time to do this. All right, 5 minutes at 3:30, we will release the answers and go through together. If you have tried it, good. Now use my techniques, my skills, okay, to reanalyze and check your answer. If you have not tried it, try it now. 4A and 4B, yeah? Okay, so I hope you use some of the skills that I have taught just now. But you see the electronic configuration, try to write it out, the electronic configuration. Then from the electronic configuration written, try to figure out what element this is, right? If you have figured out what element this is, honestly, the chances of you getting these wrong is very, very low. All right, it's very, very low. Yep. I think only maybe the last one is slightly harder because you may not know what's a monatomic gas. Monoatomic. Monatomic means monoatomic. Monoatomic means single atoms. This gas exists as single atoms. That means the atoms do not bond. What kind of elements do not bond? Monatomic means it must be a noble gas, unreactive. So which one is a noble gas? B, because that's helium. All right. So you can see, once you write out the element's name, pretty much it's quite straightforward. The next one illustrates what we have been saying about atoms versus ions. So let me just give you the answer very, very quickly. Of course, you should have started with the proton number. The proton number is 6 because it's carbon. Okay, to get the neutron, we take the bigger minus the smaller number. The nucleon number 14 minus away the proton number 6. So 14 minus 6 equals 8. The next one, please use the proton number. 11, right? And then look at the Na plus. Na plus, the charge tells you it lost 1 electron. So originally it had 11 electrons, you lose 1, it becomes 10. All right. Now these questions you must be able to do and get as many marks as you can. All right. It should be as many marks as you can. Okay. Do not leave it to chance. All right. Now for those in group 2, tomorrow our lesson is face to face. Okay. Our lesson is face to face tomorrow. All right. You need to please come along with the planning done on writing paper. There's a reason why we are doing on writing paper. It is so that you have your answers in hard copy and then you can actually do corrections, add on, and so on. Please do not do this on iPad, the planning. Do it on writing paper. I will see you at our usual timing that we fixed. I know we haven't been sticking to the usual time, but I will stick to it tomorrow. I think tomorrow I arranged for 11 a.m. in the 4 contribute classroom. So please try the planning question and then we can come and discuss how to actually plan experiments better. What are examiners looking out for? Okay, how do we usually mark? Okay, at the same time, we will try to use these questions to kind of help us revise, okay, planning and experiments in general. All right, so please come with the planning done at 11 a.m. in the 4 contribute classroom. Okay, do you have any questions to ask? Anything unsure? Okay, if not, I will actually see you tomorrow with the planning homework on writing paper done. All right, 11 o'clock for contribute classroom. Okay, thank you so much. Bye bye.